For millennia, humanity has gazed at the stars and pondered, how did life, in all its intricate complexity, first begin on Earth? The prevailing scientific idea, abiogenesis, suggests life arose from non-living matter right here, in Earth's early oceans. But what if that's not the full story? What if the seeds of life didn't originate on Earth at all, but traveled here from the cosmos? This is the audacious, ancient, and increasingly plausible hypothesis known as panspermia. Panspermia comes from ancient Greek, meaning seeds everywhere. It suggests life exists throughout the universe, distributed from one planet to another, often in dormant forms like spores. The most scientifically discussed version is Lithopanspermia or ballistic panspermia. Imagine a powerful asteroid impact on, say, Mars. It could blast off rock fragments containing microscopic life. These spacefaring rocks could then travel for millions of years before crashing onto a new, habitable planet like early Earth. Then there's the more speculative directed panspermia, where an advanced civilization might have intentionally seeded other planets with life. And older ideas like radiopanspermia, where light pressure pushed spores through space, are largely discounted due to radiation damage. This isn't just science fiction. There are compelling arguments and pieces of evidence that make panspermia surprisingly plausible, particularly within our own solar system. Firstly, extremophiles. We've discovered life on Earth thriving in conditions previously thought impossible: deep-sea volcanic vents, radioactive waste, extreme acid. These organisms, like certain bacteria, are incredibly hardy. Then there are the legendary tardigrades, or water bears. These microscopic creatures can survive the vacuum of space, intense radiation, and extreme dehydration. They're nature's tiny astronauts. We also have concrete proof of interplanetary material transfer. Meteorites from Mars have landed on Earth. And some, like the famous ALH 84001, contain structures that some interpreted as fossilized Martian microbes. Though that remains highly debated, it shows the pathway exists. Beyond rocks, comets and asteroids are cosmic delivery trucks for complex organic molecules, the very building blocks of life, like amino acids. These aren't life itself, but they show the ingredients are widespread. Finally, life appeared relatively quickly on Earth after its formation. Some argue this rapid start could be more easily explained if the seeds were already pre-formed and simply arrived, rather than needing to spontaneously generate from scratch. Lab experiments have even shown that some microbial spores can survive conditions simulating meteoroid entry, high G-forces, radiation, and even brief, extreme heat. Despite these fascinating points, panspermia is far from a universally accepted theory. Many scientists remain highly skeptical, raising crucial counterarguments. The biggest challenge is survival in deep space over vast timescales. The sheer duration of interstellar travel, coupled with intense cosmic radiation and extreme temperature swings, makes the survival of viable organisms a statistically astronomical long shot. Another core criticism is that panspermia doesn't explain the origin of life itself. It simply moves the ultimate genesis event to another planet or star system. As Dr. Anya Sharma, a leading astrobiologist, points out, while fascinating, panspermia doesn't answer how life began, only where. The initial spark remains elusive. There's also the concern of planetary protection and contamination. Our own space probes could inadvertently introduce Earth microbes to other celestial bodies. This makes it harder to identify any truly indigenous alien life. Furthermore, many scientists continue to champion abiogenesis on Earth. They argue that the unique conditions of early Earth, hydrothermal vents, clay minerals, specific atmospheric compositions, provided all the necessary ingredients and energy for life to spontaneously arise right here. So where does that leave us? Panspermia isn't a proven fact, but a compelling hypothesis. It doesn't necessarily contradict abiogenesis, but rather offers a potential mechanism for the spread of life once it has originated somewhere. If panspermia is true, even just within our solar system, it suggests life might be far more common than we think. Life found on Mars, for instance, might be a relative of Earth life, or vice versa, meaning we're not truly alone, but part of a cosmic family, born from the same universal seed bank. It forces us to broaden our minds and question our assumptions. Did life start here, nurtured by Earth's unique conditions? Or did we, in essence, receive a cosmic package delivered across unimaginable distances? The mystery of life's ultimate origin continues to be one of science's grandest challenges. But Panspermia reminds us that the boundaries between Earth and space, between us and the universe, might be far more porous and interconnected than we ever imagined. The data is out there, and the theories are evolving. What do you think? If you found this cosmic journey intriguing, please like this video, share it with your friends, and subscribe to the Content Compass for more deep dives into science, history, and the mysteries of our universe.